Let's take a look at some of the common radioactive particles that we'll look at in this course. There are other radioactive particles. You may encounter them for other particular reasons and different types of applications. But some of the particles that we're going to look at are the alpha particle. So alpha particles are the big boys of the radioactive particle world. They're essentially the same as a helium nucleus. So it's got 2 protons, 2 neutrons, and nothing else. It's a very large particle, so it's very easily blocked, but it also can do a huge amount of damage if it runs into anything. So you can think about the type of radiation is by how much damage they do, and also how easily they can be blocked. So alpha particles you can often block with a sheet of paper. So very easy to block, but if they get inside of your body, if they get into somewhere critical, then they do a huge amounts of damage. So lots of damage. A beta particle is a little bit different. A beta particle is essentially, let's take a neutron. So remember, a neutron is a neutral particle. And essentially what you're doing is you're having a neutron and you're taking an electron away from it. Now, if you take a negative charge away from something, so you're subtracting a -1, what we're going to be left with is a particle that has a +1 charge. So you take that electron away from the neutron, and you turn your neutron into a proton. So a positively charged particle. So this is called beta emission. So beta particle can be written like 0 and then 1 negative, or -1, or it can be written as a beta. Either way, means the same type of thing. And you're essentially turning a neutron into a proton. Because this particle is the size of an electron, essentially is an electron, it is going to be smaller than your alpha particle, a lot smaller. So it's going to be able to move much further. You're going to it takes more to block it, so it might require a thick piece of plastic or other device. You do want to be careful with beta emitters. Different types of beta emitters can be blocked better by different types of barriers. The last particle here we have is the gamma particle. It's our highest energy particle because essentially it's a very high energy particle of electromagnetic energy. So it's essentially like light. It's very, very high energy. It's very, very small. It can go through a lot of different things. And this is one of those ones that, you might think about like, oh, we put lead, we use lead to keep radiation out from things. And that's the type of particle that we're trying to block with lead, because lead has it's a very dense metal, and it's very difficult for the particles to get through it. There is limitations to that, though. So based on the size of our particle, we're talking about our damage as well. Remember, our alpha particle is very big, very easy to block. It's a helium nucleus, and it's going to do lots of damage. The beta particle is going to do an intermediate amount of damage. The gamma particle does the least damage, but it can go the furthest. So there's kind of this inverse relationship between how much damage something can do and how far it can go. So this is just another way of looking at our radioactive particles. So we have our alpha particle, our beta particle, and our gamma ray. The mass of our alpha particle is 4, so it's very large. Beta particle, it's 1 out of 2,000, so it's in atomic mass units, so this is already a small unit. And a gamma ray has no mass because it's essentially light. Our charge, alpha particle's got a bigger charge, so that's also going to make it be more damaging. The beta particle, it's got a -1 charge, so it's also got a little bit more damage. The gamma ray has no charge, so it's not going to interact as much with what it's going through. Our alpha particles are also pretty slow. They can really do a lot of damage. But they can't go very far. They can be stopped by paper. Our beta particle can be stopped by aluminum or plastic or there's a lot of different things that can be used to stop it. Whereas our gamma ray, it's going to be able to go through a lot of stuff. It can go right through your body if it gets a chance, but it could be stopped by lead. It doesn't do quite as much damage, though, if it does get into you. These different particles are involved in different types of radioactive reactions, and we'll talk a little bit about these types of reactions. And these are also in your reading. So alpha decay is when we have a particle breaking apart to give off an alpha particle, so a helium nucleus. So remember, our helium nucleus is our alpha particle, so 4,2 He or 4,2 alpha is our alpha particle. Our A number is going to go down by 4. Our Z number is going to go down by 2. So this just kind of summarizes some of those. We'll look at that, and there, you also have this in your reading. Beta particle goes through beta decay, is produced by beta decay, and you'll notice that the Z number, so the protons in that particle, are actually going to increase by 1. So in both of these, you're going to have new elements. So this is how we switch between different elements. In gamma decay, there's no change as far as the A number or Z number. So you have the same element throughout. You're just giving off energy. Positron emission, we're talking about a different process. I'm not going to get into positron emission or electron decay, although they can be important. Positron emission is particularly important if you are involved at all in PET scans, because PET stands for positron emission tomography. It involves positron emission. So you will maybe encounter some of these in different contexts.